Superposition theorem. Superposition theorem can be applied to circuit with multiple sources. You see, this is a kit which proves superposition theorem. Here you have two voltage sources. One is your 12 volt, another is a 5 volt, and this linear circuit have three current sources. Superposition theorem is very useful to determine the voltage across an element on current through a branch when the circuit contains multiple number of voltage or current sources. So here we will use, you see, you have a voltage source of 12 volt source. This is the voltage source of 12 volt, and another voltage source, you see, this is 5 volt. So you have two voltage sources. This is 5 volt, and you have current sources. This is one current source, this is another current source, and this is also another current source, and this is a linear circuit having three resistances. You see, you have three resistances. So in a linear circuit, the voltage across an element or current through the element is equal to the algebraic sum of voltages or currents produced independently by each source. You see, you have two voltage sources. You measure the voltage independently by the two sources. You have three resistances, 50 ohm, 10 ohm, and another 50 ohm, and also you have voltage source 12 volt and another voltage source, that is the 5 volt. So according to superposition theorem, if you measure the current using the voltage source 12 volt independently, and then you measure the current by using 5 volt independently, and then you measure the current. This is the multimeter through which you measure the current. So if you measure the current by using both the sources, that is 5 volt source and the 12 volt source, you measure the currents by using the two sources, then you will see the currents will be same. So this is the problem. You have given three resistances, 50 ohm resistance, another 50 ohm resistance, and a third one is your 10 ohm resistance. And what you do, this is R2, let us say, R1 50, R2 10, and R3 is 50. Okay, so you have given three resistances and two voltage source. So in this given circuit, using superposition theorem, you calculate the voltage drop across each resistance and measure the voltage drop experimentally. Similarly, you calculate the currents I1, I2, and I3, and experimentally you measure the currents. You first calculate the current, then you experimentally measure the current. So first you do, what you do, first you consider the 12 volt source and measure the current. So you see, this is the circuit diagram. By using a 12 volt source, you have three resistors, R1, R2, and R3, and how you calculate the current, you see, this is the 12 volt source as shown to you. It is connected to the circuit, and it is also connected to the voltmeter in parallel. You connect the source 12 volt source to the voltmeter in parallel. So the input voltage is 12 volt. Now you calculate the total resistance of the circuit. So in the circuit you have given three resistances. First you calculate the equivalent resistance between R1 and R2. Since they are in parallel, so R12 will be equal to 58.3 ohm. I have calculated it. You use the formula for the parallel connection, and if you find out the calculate the values, then it will be equal to 8.33 ohm. The R12 will be 8. Then you see R3 is in series with R12. So for parallel it is 8.33 and for series plus 50, so it will be equal to 58.3. So the equivalent resistance will be equal to 58.3 volt. Then what will be the current? The current will be equal to voltage divided by the resistance. So it will be equal to 205.8 milliampere. So now let us measure the current. So I am measuring the current. You see, you short circuit the other two current ports or current sources. I am short circuiting the current sources to measure the current I1. First you measure the current, let us say I1, and you see I am short circuiting. I have short circuited the other two ports, and you connect this port with the milliammeter. To measure the current, you connect this port with the milliammeter. This is one port. I am connecting the other port. Okay. I have connected the other port to calculate the current. Now you see what is the current in the milliammeter and what is the voltage, input voltage. The input voltage you see it is 12 volt and the current is equal to 205, nearly 205 to 206 milliampere. So this is the same as the calculated value, 205.8 milliampere. And using the current divider rule, what we have discussed in the previous video, you can calculate the current I2, current passing through the resistor R2. For this you use current divider rule, and using current divider rule, the current in the resistor through the resistor R2 will be equal to 171.5 milliampere. Okay, you watch the previous video to know this formula I2 equal to I1 into R3 by R2 plus R3. So to measure the current I2, what you do, you short circuit I1. You short circuit the port for I1. You see I am short circuiting the port for I1 and connect the port for I2, that port you connect with the milliammeter. You see this is one port of the milliammeter. Then you connect the other port to the milliammeter to measure the current I2. See I am connecting it and the input voltage same, input voltage is same. So the measured current you see it is nearly 171.5 milliampere. Okay, so you see our calculated value 171.5 milliampere, and you simply calculate the value of I3. You take the difference of I1 minus I2, this will be 34.3 milliampere. That will be the current passing through the resistance R3. And for this you short circuit the current port I1 and the current port I2, you short circuit it and you connect the current port for I3 to the milliammeter. I have connected it. I have connected the two port, and what you do, you short circuit also the 5 volt source to measure the current. You see I have measured the current and use the similar procedure for 5 volt source. This is the reading for 12 volt source, what we have taken for 12 volt source, the calculated value and the measured value, you see the difference. And using the 5 volt source also, you measure the current, and also experimentally you determine the current. Exactly in the same way you can do it. The procedure is same, and these are the current values using 5 volt source. These are the current values for 5 volt source, you see. And according to superposition theorem, if you connect both the sources simultaneously, that is 5 volt source and your 12 volt source, then what will be the current? The current should be the difference in current should be I1 minus I1 dash. Through R1 it is I1 minus I1 dash, and through R2 it is I2 minus I2 plus I2 dash. Okay. And what is the difference? I1 minus I1 dash. This is the calculated value, and when you connect it, you will have the measured value. Similarly, for R2, the current will be I2 plus I2 dash, and for R3 it is I3 dash minus I3. So from this table you can see or prove the superposition theorem, that is, if you measure the current independently by using 12 volt source and 5 volt source, that will be equal to the current when you measure using the two voltage sources, that is 12 volt source and your 5 volt source. So this is the table from the experimental results what I have got. So you do it carefully. And this is the circuit I have connected using the two voltage sources. This is your 5 volt source I have connected, and this is the short circuit connection, and this is the milliammeter connection. You see, same way as I have done in the independent measurement, you do the do the experiment in the similar case as I have done in using independent sources, and you see the magnitude of the current. As I have shown you, the magnitude of the current using R1, that is equal to 182, then using R2 230 and 45. And this is the tabulation for voltage drop across each resistance. For source voltage 12 volt, the calculated value of resistance using the resistor R1, that will be equal to I1 into R1. I1 is 205.8 milliampere, R1 is 50 ohm, so it will be equal to 10.29 volt. And this is the measured value across the resistor R1, same, that is 10.28 volt. Similarly, across R2 you have 1.71 volt, and across R3 it is 1.7 volt. And for using the voltage source 5 volt, you can also find out the voltage drop across R1, which also exactly match with the experimental value. Similarly, across R2 it is 0.71, 0.7, and 4.2 volt, 4.2 volt across R3. And if you use both these sources simultaneously, that is the source 12 volt and the source 5 volt, and calculate the voltage, then it will be equal to same formula. Use the same formula I1 R1, V1 is equal to I1 R1, V2 is equal to I2 R2, like this. And if you calculate it, then this volt will be equal to 9.5, which also exactly match with the experimental value, and for R2 also it exactly matches. So from this you can conclude that if you have a linear circuit, in the linear circuit the voltage across an element or current through the element is equal to the algebraic sum of voltages or currents produced independently by each source. So this is your very important theorem called superposition theorem, and in the next video we will discuss about reciprocity theorem and maximum power transfer theorem. Thank you.